Welcome to Let's Code. We're working on the Lunar Lander project, and you join us at a particularly exciting juncture in this project. Last time I was working with Mike and we roughed out a sort of a proof of concept. We just said, can we even do anything? You know, no package, no design, no API. Can we just do something? I think the first thing we did was just set the altitude of the rocket and then gradually decrease it until it gets to zero. So, you know, world's least exciting flight simulator. You have no control whatsoever. All you can do is crash. So that worked fine. And I'm now here with Bukola, and we're going to try and extend this a little bit. And we have some possible to-dos here, which is features that we thought we might want to add. But I feel like I want to get some tests into this, because I'm a test-loving kind of guy, and it makes me nervous when I don't see any underscore test files in my project, right? So let me just show you what it does right now. I hope it still works. All right. So it tells us that we need to land at 10 meters a second or less. I've no idea whether that's realistic. I don't think the real lander could survive that speed, but never mind. We start out at 100 meters, so we're kind of on easy mode. Velocity minus 100 meters a second. So if we don't do anything else, in 1 second, we'll probably hit the ground a bit too fast. So we can enter the thrust that we want. Let's say 100. Yeah, we survived. So that's good. Yeah, probably not going to wow the world of Xbox anytime soon, right? But it's something. So let's look at the code. Shall we code club this? Because we know how to do that, don't we?
Yeah.
Should we just run through and see if we can understand what's happening? Why don't you kick us off?
That. Yeah. Okay. Having not looked at this code again since like weeks ago, so we need to land safely at a vertical speed of 10 milliseconds?
Meters per second.
Meters per second.
Yeah, so we're using proper SI units here.
Ah.
No nonsense about miles per hour.
Okay, so we've got an altitude of 100 what?
Meters.
Meters. Yeah. Velocity of minus 100.
Yeah, so we're using minus here to mean downwards.
Okay.
Which makes sense, doesn't it?
Yeah. And acceleration minus as well.
Yeah, so we're accelerating under gravity. So the moon's gravity is accelerating us at about 10 meters a second, which again I'm sure is totally unrealistic, but it doesn't matter. We'll bike shed these exact numbers later.
Okay. Our thrust is 0. Why is that?
I guess we just start, with the rocket engine shut down, and now, you will be able to increase that thrust later on.
Okay.
But that's our starting condition.
Okay. So we've got a simple loop, and we are looping the altitude for altitude. Oh, this is a for loop, right? Trying to get my brain back.
Yeah, that's right.
Yeah.
Yeah, actually, let's make this name up. Let's make this name a bit better. We're not that short a space that we can't say altitude. So yeah, as long as the altitude is greater than 0, we're still alive.
Yeah. And where are we counting? So the math is happening somewhere below. So we're adding velocity to altitude. Oh, you've just renamed. Okay. Yeah, I wondered what happened there.
Yeah. First of all, we'll draw the amazing graphical interface that we have
with our print. Okay.
Yeah, this is a little bit short of VR, isn't it? But you can imagine that, I mean, I imagine in big Xbox games and things where they have 3D and graphics, indeed. There's something like this at the core of it, isn't it? I mean, there has to be
Which
some,
makes sense.
yeah, there has to be some physical model of what's going on.
So these are like our pixels for now.
Yeah, and we sort of represent the state of the world in some way, and then we modify the state of the world based on maybe what the player does. And then we sort of, we have some input, which is the player's controls, and we have some output, which is kind of telling the player about the state of the world. Now, that could be anything from rubbish CLI interface like this to 3D graphics, but that's one thing we kind of want to do, isn't it? Is separate that input-output from the core logic. So that's one thing we can think about when we're refactoring this.
Okay.
Anyway, you're doing very well. Carry on.
So our output right now is the altitude. So we have the value of altitude, the velocity, and the thrust. And we see that enter thrust setting. Okay, so are we reading from the terminal now?
Yes, we are.
All right, yeah. So the next line, we're reading the value entered.
Yeah, there's this very useful fumpt.scanln.
Are we using that to calculate? Are we adding that to the velocity? That's all we're doing, right?
We are reading the desired thrust. So if you say I want 100 meters per second, you'd enter 100. And then here comes the physics.
Yeah.
This is really cool. So any physicists or even high school physics teachers, or let's face it, high school physics graduates who are watching this may have serious problems with it. But whatever, don't write in.
It's not real physics, right?
Yeah, but it's
a simulation.
Yeah, but at some level, this does reflect how reality would behave.
How reality.
Doesn't it? In that, our height above the ground would increase by some factor depending on how fast we're going, or in this case, decrease. But of course, we know velocity is minus, at least at the moment. You can imagine if you fired the engine too much, you'd stop descending and then start going back into orbit again. And you're like, no, we missed the moon altogether. That would be bad. Actually,
I actually quite like this because it's like this is like the minimum. I mean, this is like the tiniest representation you can have of. Yeah. So I like it.
Well, Mike
and
I were actually
to me.
Yeah.
I mean, without having to look at a whole bunch of physics calculation.
Yeah, exactly. So Mike and I were quite pleased about how simple this came out, because I thought it might be harder than this. And of course, there's more we could do, but I just wanted to really get the absolute basics down and have something that you can play from end to end before we started refining it, because, as a mentor, I've got a bad habit of assigning projects to mentees, which seem super easy to me, but then they turn out to be way more difficult than I thought.
Simple is never easy.
Yeah, of course my mentees are brighter than the average programmer, so that's no problem for them. But nonetheless, I found it's really useful to just get something running completely before we actually start designing it, if you like. It's easy to imagine sort of spending loads of time on a bunch of tests and packages and subfolders of packages and interfaces. We could throw all that stuff at it, and at the end of the day we might say, yeah, turns out this game isn't actually the one we wanted. It was no fun to play. I mean, I'm not saying this is super fun to play, but it's a start. So, yeah. So you rightly said we update our altitude based on the velocity. Now we can update the velocity based on the acceleration. That's just how the velocity is changing over time. And so this is actually acceleration due to gravity. So I think we should probably change that name, don't you?
That'll be helpful.
let's make this gravity. Again, physicists would be angry about this, but we know what it means.
Because that's not what it means.
That's right, but we'll just pretend it is. So the three things that are happening are we're changing position in space at a certain speed. We're changing our speed based on gravity.
Yeah.
And we're also changing our speed because we're firing a rocket engine. Maybe.
Yeah.
So every time we go around this loop, we have updated the state of the world, if you like. And the player has some effect on this by changing the thrust setting. So, I don't know, do you remember ever playing this game when you were a kid? Or, you know,
Yeah, sort of.
less demanding on games than you might be nowadays.
Sort of, yeah. I sort of remember playing something like this.
Yeah, I remember something like this, and it was, you know, reasonably fun because it's not trivial to win. You know,
Yeah.
Of course, in the real game, you start from a lot higher up, and you're traveling faster, and you have less thrust and stuff, and you also have fuel, which is one thing, yeah, to do, fuel. So,
are we going to add that to the list then?
yeah, so that's a little extra challenge in that you can't just use as much thrust as you want. You've got to think, what happens if I run out of fuel?
Oh, that's already there.
Yeah, and one other thing we're not detecting is you missed the moon completely and flew off to some other planet. We could add more planets. That'll be in the 1.1 release, extra planets. So, please continue.
Okay, so I assume, well, not assumption really, our altitude would at some point be greater than 0?
Yeah, or the fact that we've got past the end of this loop tells us that it's no longer greater than 0. So it's either 0 or maybe it's negative because we made a huge crater in the moon. But either way, this is now
That
the end of
happens.
it's the end of the game here, for better or worse. So what happens?
So what are we doing with our velocity? Here we are absolute. What absolute are we getting from this? Is it
Yeah,
forgotten this formula now?
yeah. The thing is, in order to know if we landed softly enough to walk away, the velocity wants to be less than 10, but of course it can be up or down.
Yeah.
And I can't really imagine that you could land with a positive velocity greater than 10, but you know, if you did, that should also kind of be a problem. So MathAbs just gives us the absolute value, chop off the minus sign in effect.
Oh, so that's just not so.
Yeah, you could imagine if you said,
Okay.
yeah, you could say if velocity is less than minus 10,
Yeah.
but then that's wrong. Because, you know, minus 20 is lower than minus 10, but that would be way too fast. So we would say greater than minus 10, but that's just confusing. So you might say this is still a bit confusing, but maybe it's slightly less confusing to just say the absolute value of the velocity, ignoring sign, is below 10. So that's a happy outcome.
And that's a safe landing.
Yeah.
So I'm quite intrigued by the parsing of the string that we've got inside of the print
Oh, yeah.
function. So we've got F. So I imagine that's for the digital, the digits, right?
Yeah, so scanln takes...
No, not that one. Just the
not
one,
that one.
After the absolute math formula.
Oh, yes, this you mean.
Yeah, yeah.
Yeah, that's right. That is... the verb we're actually using here is %.1f. So f because it's a float 64.
Okay.
And .1 because we want 1 digit of precision after the decimal point.
That's right. Okay.
So otherwise it'd be like, yeah, you landed at 0.0000001 meters per second, which would be annoying. So that's quite helpful. So, and it's the exact same thing here.
Yeah, if it's not less than 10.
Yeah. So just to, because it's actually quite rare to use scanln. We all probably print stuff to the terminal pretty often, but maybe we don't read it. So it's quite nice to see this because just like println, it takes any number of empty interface objects. So, any number of values, and it'll read a line of input from standard in, and it will try to convert everything that it read into the variables you gave it. So it's like, I have a line of text, you gave me a pointer to float 64, so I'm going to try and turn that text into some float 64 value. And we don't handle any errors from that, so that's a bit of a red flag there, isn't it? Uh-oh, we didn't check an error. And my mentees will be laughing now because I'm constantly going on about them, about the importance of checking errors.
Do what I do.
Yeah, exactly, and I didn't do it, so. Code review
How do
comment.
we test this? This will be really interesting to test.
Yeah, exactly. So that's code review comment accepted. We need to check that error, and the other point you made is an excellent one in that we're reading input from standard in, so that ain't going to work in a test. And we're also printing output, which would work in the test, but we don't want that to happen because tests should be seen but not heard. So, like my mum used to tell me children should be. They should basically be completely silent unless anything's wrong, in which case they should tell you exactly what's wrong. And that's what children indeed do, isn't it?
All the time.
So, we have, and it's a general problem about testing anything with a command line interface, or any terminal interaction, let's say, isn't it? That we need some way to supply fake input, and we also need somewhere to send output to which doesn't appear on the terminal when I run go test, but I might want to be able to look at it to see if it's what it's supposed to be, so I can't necessarily just throw it away, for example. So let's think about that. So we definitely want to add some tests here, don't we? And I think, despite the fact that I'm always banging on about the importance of TDD and testing in general, and my For the Love of Go book series now available, the very first book is about learning to test stuff. So literally the first thing you'll do in Go is write a test. And I haven't done that. And does that mean I'm a tremendous hypocrite? Yes, but that's not relevant now. The reason for doing this is basically, I don't know what I would even test, right? I mean, my test would have to import some package and it would have to call some function, but I don't know what the package or the function would be because I don't even know what it does yet. So I don't know if you do this as well, but sometimes you have a problem to solve and it's so well specified you can actually sit down and write tests.
Yeah.
Somebody said to you, yeah, it should have a name function, and if you call it, you should get this back. But very often it's just, you need to solve this problem, and we don't really know how we're going to do it. And one way to work that out is to write something like this. I call this the shoddy main.go technique, except I don't use the word shoddy. I use stronger language when I'm not on YouTube. But the idea is basically just do something, prove the concept, get your ideas straight. I had my velocity the wrong way around, for example, so we just accelerated off into the galaxy. So you sort out little things like that. And then once you have it the way you want it, now you can start to say, all right, I could imagine that this code was inside some package. maybe even have an idea what the package would be called, and maybe I know what. Start to have an idea of what functions should be in it. So we can start thinking about that, can't we? But I guess, the reason for this boring digression is basically to say this is why we've not done this test first. Is we've done the shoddy main.go to work out what we even want to do, and now we're going to do a test first. So, okay, you help me. What do we need to do first here if we're going to have some tests? We need a test. We need a test file, don't we? Let's start with that.
Yeah, we need a test file.
Let's suppose the package is called Lander. We might think of a cool name for it later, but let's assume it's going to be package Lander. So this might be landertest.go. Okay. I know what to write here. So I could have said package Lander though, couldn't I?
Yeah. Are we defining the package or just the file?
Well, I haven't got that far yet. So I'm saying given that I think my game package is going to be called Lander, my test package is going to be called Lander Test, and the reason I want a separate package is so that I'm forced to import the package first off. So if I was inside package Lander here, I wouldn't need to do that. I could just call whatever I wanted. But I want to kind of put myself through the same pain that users of my package would experience if they wanted to use it. So if my import path doesn't make sense or is too long or annoying, I'll find out here. And another point that probably occurred to you before, but a lot of people overlook this, is the names that I use, I'm going to have to prefix them with Lander.
Yeah.
So suppose I had some object that represents the Lander. I might call it Lander. And now in my test I'm writing about Lander.Lander.
Yeah.
That's dumb, isn't it? But you'd never spot that if you were inside your Lander package, and until you saw someone who'd imported your library on GitHub, and you were like, Lander.Lander? That doesn't make sense. What idiot wrote that package? And you do see that. So, okay, well, I know I've got to import testing, so let's do that. I'm doing the easy bits. Should we just do the most basic test of anything, which is just to say, let's just do a null test. So we know all tests take the magic testing.t. Always makes me think of a cup of tea, which is nice. It's like, while you're running your tests, here's a refreshing cup of tea. In benchmarks, it's a testing.b, and I imagine that stands for bun.
Your association with food.
Yeah, that's just my private madness, which you probably don't really need to know about.
It's fun, but it's not good for people who sit in front of the computer all day.
Right. So, I know I'm going to want to import my Lander package, so let's do that. So far, so good. Oh, thanks for helpfully removing that. Remove my unused import, which is great. So, let's run go test, and I know this isn't even vaguely going to work, but let's just see. All right. The compiler is already angry with us. And so is somebody else by the sound of it.
Yeah, right. It's my daughter. She came to get paper.
Okay. We'll put her on the next episode, maybe. So we have a problem here because we've got two different packages in the same folder, and we know that's not allowed. What could we do?
Create one.
Yeah, we're still going to need a main package in order to run this. We're hoping main will be pretty small, and maybe it'll just call into Lander, like be like lander.run game or something. You know, that would be ideal, wouldn't it?
Yeah.
Any logic that we have in our main package is not going to be available to anybody who imports Lander. I like to phrase this as they can't import your main package.
Yeah. Pretty much.
So anything in there is useless to anybody else. So we'll still need main, and we need to put something in the subfolder. The question is, should we put main in the subfolder or should we put Lander in the subfolder? I think either of those is fine.
Lander in a subfolder?
Yeah, you could do that, but then the thing is, if people are importing this library from GitHub, which I sincerely hope they will, to create more interesting games, then there would be an extra directory in their import path, right? It would be import github.com/bitfield/lander/lander. Now that's going to irritate people.
Oh, we're already in Lander, aren't we?
Yeah, that's right.
Okay.
And we could maybe call it something like PKG, like you might have seen this. Sometimes people, they have a Go repo, and they put all their Go code in a subfolder called PKG. And I'm like, what's that about?
It's just convenient, right? Naming is like one of the hardest things.
Oh yeah,
and
definitely.
I'm guilty of leaving that to last as well.
Yeah. And I think probably, project structure, package structure, folders and so forth is one of the chief things that people love to bike shed about in Go. And we probably waste a bit too much time on it instead of getting started. I often get stuck right after I've typed the keyword package, right? Because I just don't know what the package should be called. And I'm like, I can't proceed until I've solved this. But
I struggle with that. And I wonder if there's an easy way or if there's a recommended. Well, there are recommendations. It's just I'm never sure.
Yeah, well, my technique for getting around this is just to call it package stuff or package rubbish or something like this. The idea being now I can get on and write my package, and some way into that I will probably figure out what the right name is.
Yeah.
Or maybe I'll think of it in the bath one day or something. But the point is it needn't hold me up now. And if I make it as silly a name as possible, or maybe an obscenity, that will remind me to change it at some point in the future. Don't forget to do that, by the way. Otherwise,
Yeah, let's do that then.
yeah, otherwise you'll get kicked off YouTube. All right. So one pattern that I use a lot is to put I have my package, which is all about being a lunar lander, and I also have a lander command, which is a CLI that runs the game. But I don't have to run it that way. I could run it in a web page, for example, or I could do it in a GUI window. So the lander command is sort of conceptually quite separate from lander. So we might put it in CMD. It's sort of conventional. Let's put main.go in there. And now we sort of have this structure, which looks a bit nicer, doesn't it?
Yeah.
This is Lander, so all our Lander related stuff can go in here. And my license file, of course, which is very important because without that, no one can use this software in any way. And that's one big mistake that I see in a lot of open source repos is they simply forgot to make it open source.
Well,
I mean, I'm sure that doesn't in practice prevent anyone from using their software. But,
no, it doesn't, does it? No.
But if they tried to use it for a real moon landing and it all went wrong, and somebody ended up being
I hope
sued,
no one does that.
yeah, well, you'll find that I have provided no warranty of any kind. Yada 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 yada. Don't sue me. Yeah. So that's why we have that. So we should be a little further, shouldn't we? We've fixed that package problem.
Yeah.
Still not good, because cannot find package lander. Well, that's fair enough, because we haven't actually written it as such. But specifically saying cannot find package Lambda, what that's really complaining about is it can't find a go.mod file, isn't it?
Yeah.
So it's saying I know we're in a directory called Lambda, but that's not good enough for me, because there could be any package in there. What I need from you is some kind of legal documentation that says, yes, this is where the Lambda package lives, and we can do that very easily. I won't worry about the import path for now, just init Lambda. So now I've done the paperwork, should be able to find that package, shouldn't it? Oh, so we got a bit further. Now
well,
it's
at
not...
least it's talking to the package now.
Yeah. So every programmer knows the joy of getting a different error message. It means we made progress.
Progress, yeah.
So now it says no non-test Go files in Lambda. Yeah, fair cop. There aren't. And as you know, any file ending in _test is magical, so it's not built as part of the project. So if you ignore all files which don't end in _test, there are no Go files at all. So let's fix that. Okay, now it can hardly complain about that, can it? There's a non-test Go file, so we should get a different error, and we do. Okay. This makes sense, doesn't it?
Yeah.
So we're in lambda.go, line 1, column 1, expected package, but found end of file. So apparently I have to actually write some code.
Yeah.
What a drag. Well,
it's the Go way.
yeah, I know I'm legally obliged to write package. That's all right, I can cope with that. And I have to give the package name, and we've decided it's going to be Lambda, so that's cool. So what do you think? Are we good?
Not quite. I mean,
Well,
we've got Lambda now, haven't
yeah.
we?
Let's narrow down the question a bit. Do we think this will compile, first of all?
Did it compile?
VS Code says
Should.
not. But oh no,
Should now, shouldn't it?
Yeah, actually that's fair, because it's saying you imported Lambda but you didn't reference it. Yeah. And if I was to save it, it would remove that. So suppose let's refer to lambda.something. Lambda.something. Let's see now. Okay.
That doesn't exist though, so it probably still won't build.
Yeah, that's believable, but at least now I know why. So if I was to say just something, okay, we should now be passing, we should be compiling and failing, shouldn't we? Or should we? Actually no, because this test should just pass with the variables not used. Let's assign it to the blank identifier just to keep the compiler happy. Cool. Tests are passing. All right, we're done. Let's hit the pub.
That's how it works. It tested with no tests.
Yeah, somehow I feel we need to do a little more, but I'm pleased we did this, because the thing is, every single one of these semi-deliberate mess ups, will have been seen by somebody at some time, won't it? So
yeah.
So if you get this, now you know what the problem is. If you get this, you know what the problem is, and so forth. So now we need to do a bit of designing, because we want to say, okay, I want to call some function in my test. So what function am I even going to have? So you could, well, I don't want to influence your judgment. You tell me, what do you think? what would make sense to move into the Lander package?
You mean just lift off here? Or how do we design our functions? Or if there will be more than one?
Yeah, we're saying some or all of this logic here should
Need to.
end up
Okay.
in the Lander package, and then we can test it. So, what options do we have even?
Move I know we need to move the math bit
Yeah,
into a self-contained function, something called velocity.
yeah, we can definitely do that. We could just lift and shift the whole thing as a block, couldn't we?
Yeah, off of main, if that's what we're doing first, and then we try and start picking things apart.
Yeah, you could imagine that.
That's the aim.
Yeah,
Yeah.
in a sense, we already have the function that runs the entire game. So we could just move this into Lander, rename it run game or something. And
Yeah.
so far, so good. We have some dependency injection issues with the test, as you pointed out earlier. But we can solve those. Or we could say, well, there's some structure in this. There's like intro, set up the world, initial conditions, the main game loop, and then sort of, ending. And you could have things like, would you like to play again? YN.
Yeah. Makes sense.
Yeah.
It already has some structure.
Yeah, but I think so. Often, moving the entire thing is conceptually easiest because it lets you put off decisions about how you break this down into functions. But it gives you test problems because imagine that we want to just simply test this function. Not only have we got to pass in, we've got to pass in a fake input, and we also have to supply player inputs, don't we? So we could imagine, say it runs for three rounds or something, and you put in different thrust settings, and it has to basically run the game and then end whatever. So that's super complicated. And I'm lazy, so I don't really want to do that. So I'm kind of thinking, is there anything we can identify here which we can kind of pull out into its own block, like you said about the physics update? And then that would be super easy to unit test, wouldn't it, in theory?
Yeah.
What could we grab out of this?
They're all intertwined.
Yeah, well, that's the thing. That's the slight disadvantage of writing the entire game first. Is because we didn't do this test first, we have something that's completely untestable. And that's, this happens a lot. What we can then do is we can start to say, suppose I just break it up into arbitrary chunks. Maybe they're not the right chunks, but whatever. I just want to get some tests because right now, if I toggle test coverage to see what is tested, the answer is nothing at all. So I have 0 test coverage. I know you specialize in 100% coverage.
No, I don't.
So
it's always best effort, and when it happens, it's a joy.
oh, you're just lucky that time. Okay. Well, we'll see how far we can get. So
when I do things well the right way, and that happens, then it's amazing.
yeah, it's nice, isn't it? So maybe this is also a block of just set up my world. And one interesting point about this is that these variables, we probably don't want these to just, since this will no longer all be in one function, we won't be able to just have these variables. We'll need to make them not global, but shared in some way.
Yeah.
So one way to do that might be just to make them global. It's not a great way, but it's a way. Let's suppose we did that then. Suppose we had some function like setup or init, let's call it. Sounds more technical, doesn't it? Let's make an init function that we can call, and that sets everything to its initial values. And then we can test in the test that it actually did that. So I think that'll start to give us a clue about what names things should have and so forth. So let's call it init game. Okay. So as you know, I like to write tests by specifying my want, and then I work out what I got, and I say, does want equals got? That's a nice simple structure for a test, isn't it? So what's our want here? Let's punt that question, and then we'll say, let's call lambda.initGame, and now we've got some little design decisions to make. Does it take any parameters, for example? What do you think?
It has to if we if we need to like do these side effects. But then I'm not sure.
Well, you could say, yeah, you could make it take parameters, and you can say initialize the game so that you're X thousand meters above the surface or whatever. But let's say, for the sake of simplicity, it just doesn't take anything at all. So just say initialize everything to its default values, and there's no way to change those. There's no knobs you can tweak. It's all preset. But having called that, then we should be able to check some facts about the world, shouldn't we? Like, we should be able to check that the altitude of the lander is, let's say, 100 meters.
So are we going to initialize with those values then? Or, I mean...
Well, we'll tweak the values later, but let's remind ourselves what they are. So we're saying starting altitude is 100, starting velocity is minus 100, gravity is minus 10, and thrust is 0. So we could check all of those things. And what are they? This is the question. So is it something like, do we have something like lambda.altitude? Or does that even make sense for them to be separate variables? Or do you think there should be some kind of struct type which contains, you know, the entire state of the world as fields or something?
That makes better sense.
And
having
if
a
so,
struct for it.
Yeah, I kind of feel like anytime you have a bunch of related values like that, I don't want to remember 5 different names. I just want to remember one name and then say, okay, there are fields on that struct. And you sort of have to think, well, what is the object that has these attributes? You know, are we saying it's the lander vehicle itself, which has an altitude, velocity, and so forth, or is it kind of the world? You know, if you're writing any kind of simulation, all games are effectively simulations, aren't they?
Yeah.
You must be faced with this kind of decision, mustn't you? How am I modelling things? Am I modelling it as like there's a world object which contains everything, players, vehicles, buildings, or do I have individual objects, each of which maintains their own state? For example, we mentioned this last episode that I was saying the original Elite game. Did you ever play Elite?
No.
Ah.
I probably have. I'm too old now.
Well, it was another spaceflight game, and I
There you
think,
go.
yeah, because I was reading the source code, which is online. There's a great website where you can see
Oh,
commented, disassembled Elite source code, which is really fun because they were doing some amazing things with the old BBC Micro, which wasn't a very high-powered machine, but nonetheless they got real-time 3D graphics out of it, including hidden line removal, which is not trivial, and there's no GPU. It's all done in software. And one thing they did was, everything that you see on screen, like moons, space stations, other ships, they're all of the information about where they are is stored relative to your ship. So you could think of it as like it feels to you like you're flying around in the solar system, but in fact you are completely fixed. You are
yeah.
the center of the universe, and you never move. Everything else just moves relative to you.
Which makes sense.
Yeah, and it makes it super easy to draw the stuff on screen since that's
Yeah,
what you care
yeah.
about. So if you're traveling towards the planet, in fact, your ship stays where it is, and they just move the planet closer to you.
Oh, now I want to study physics.
Yeah. So we maybe have a similar sort of choice in that if all we have is a lander, then it makes sense for the lander itself to be the state object. But you could imagine maybe we extend this game so that you maybe rendezvous with another ship, the command module, let's say. Now, if all of the information about the world is stored in the lander, where do you store the stuff about the command module? You'd need something
Yeah.
else. So,
So, yeah.
whenever you have a problem like this, my way of thinking about it is usually what makes the code simpler. So I want to just be able to write reasonably straightforward code. And I think that would be to have a lander object. We don't want to call it lander.lander, so what should we call it? Like lander.rocket? Lander.ship?
Yeah. Dot ship.
Or maybe lander.lander is okay. I don't know. Let's go with ship. So, we're saying there's some kind of struct object, lander.ship, and it should have some value. So let's say, so now we have an idea about what our want is, don't we? We want a certain lander.ship value. What if we call it state? How about that?
State. It could be state of anything. So lander state. Okay.
Yeah, well, we're sort of avoiding prejudging that whole issue, aren't we? By just saying
Yeah.
state, we're saying state of the world,
Mm.
which includes the lander, of course. So we want a lander state where altitude, we know this is going to be an exported field, don't we?
Yeah.
Because otherwise we wouldn't even be able to test it. But so this is kind of helpful, isn't it? In that we're already making important decisions about what objects do we have. Is it a struct type or are they separate variables? What things are exported and so forth. And that's all because we're trying to test it.
Yeah.
So that's actually really useful. But I think this is one reason people are sometimes resistant to TDD, isn't it? It's hard to write tests because we're having
It's
to have
harder than write. It's harder than implementing the logic, for the
Yeah.
problem you're trying to solve.
Exactly, that's exactly it. Is last time Mike and I just blazed through this. No
And
trouble.
I had fun watching it.
Yeah, no trouble whatsoever. But this is brutal because now we're getting down to the real work, if you like, real engineering.
It's always the real work, the testing.
Yeah, that's right. The nice thing is though, if you can get through writing the test, then the implementation is trivial.
Yeah.
Or it should be, because you've already made all the hard decisions. Most times when you have trouble writing code, it's not because you don't know how to do something in Go. It's because I don't know what the name of this thing should be. or I don't know what kind of variable it should be, or if it, if I'm calling a function, what parameters should it take? That's why you get hung up on writing code. And of course, if you've done the test, you already know because you called the function, so you know it doesn't take any parameters. Or if it returns something, you already know what it returns because you're testing it. So problem solved. So let's just do this. So we want all of these. Let's go multi-cursor. That's not going to help, is it? Can I do uppercase?
Mm.
I had a vague memory that I could kind of change case of selection, but maybe not.
Sorry, I couldn't help my brain switches between Windows and Linux now.
Yeah, right. Don't worry about it. You're still thinking in C#. So,
I think in both now and 2 different environments.
Yeah.
So.
Okay, I achieved uppercase. So score 1 for me. Okay. We don't need those. We do want some commas here. Not there. There. Okay. Format? No. Not quite ready yet. So that's what we want. That's the state we want.
Yeah.
And we want the game state, if you like, to be equal to that wanted state.
Yeah.
So what's the game state? Maybe it's just lambda.gameState or current state or something like that. Because this is our type, isn't it?
Yeah.
So
initial state.
Yeah, we could call it a state vector, which you can tell I've been reading physics books.
Yeah.
But that is actually what they call it, I believe. And the computer inside the lander or the shuttle or the ISS or whatever you like actually has this state vector inside it. In that it knows, hopefully, what its altitude and speed and so forth is. And every so often they ask the ground, hey, can you see me on radar and just check if I am where I think I am? And the ground will upload the state vector that they think it should be, and it compares the two things and says, oh, I was way off. Or not. So we're getting there, aren't we? So if lander.gameState is not equal to want, let's call it want state. Let's do that the other way around. Fail, right? That's not right, so we to fail by saying something like want this, got that. This is always my default test failure message. It's just it doesn't match. Yep. Want state lambda.gameState. Okay. This is not compiling for a bunch of important reasons. I haven't defined the lambda state type, and I haven't defined init game or game state. I'll just quickly do that. What is? What's the typo?
Yeah, it was one state, you were just missing the E, so you
Oh yeah, right. Okay, so I've said type state as a struct, yada yada, altitude, something, 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 float 64, velocity, gravity, thrust. That'll do. Game state. Oh my god, a global variable. Have this man arrested. Function init game. Takes nothing, returns nothing, does nothing. Easy. So that code was trivial. This was really hard. Of course, I haven't actually implemented it yet, but that's okay.
Yeah.
We would like to just get to a failing test. And indeed, we do. So that's cool. So it said I wanted this state vector. What I actually got was this. And it's not even vaguely right. So
Yeah.
it's like you spelt Christmas without getting any of the letters right. So we would know what to do next time, wouldn't we? Is one thing we have to do is make this test pass.
Yeah.
And we know exactly what init game needs to do now. So we've kind of defined it. You can now take, you could give this repo to someone and say, there you go, you know, make this work. That's your job. And then come back to me when you're done. So that's great. And I think we cracked a few important design problems there, which is great.
Yeah. And hard.
Yeah. So that's really good progress, I think.
Yeah.
Thanks so much for helping me out with this. I think we've really moved it forward.
Thanks for inviting me.
What should we do in the next episode? Whoever it ends up being, so you can assign them tasks now. You can say, what should they do you think?
What should they do?
Yeah, well, we know we need to make this test pass, but that's okay. We kind of already have that code, so we're just we're lifting and shifting stuff from main into Lambda, and that's okay. So what should we do after that? Maybe write another test?
Right, yeah. I mean, what other tests? We need to, you mean after making it pass then?
Yeah.
Yeah, we should go back to the main function and lift. Well, we want to test what we've changed first inside of here,
that's a
and
good
make
point,
sure it still works the same as before.
That's right. We didn't complete this refactoring until we cut this code out altogether, and instead we say something like, we'll do something like import lambda, and then we'll do lambda.initGame or something, and then it should all work exactly as before. So we've done a great deal of work to no apparent purpose. But that's just life as a programmer, isn't it? But on the plus side, we will have a test, so we'll be happy about that. All right, I will release you to go back to your other full-time jobs now.
Thanks very much.
Thank you.
I'd love to see how this ends. The Lambda game.
All right,
and the exercises. Yeah,
and you will keep watching the skies.
Thanks very much.
No problem. Bye-bye.
Bye.